Alright, section 2. Graph quadratics and vertex or intercept. So those are two new forms. You know standard form. Now you're going to know vertex form and intercept form. Okay? So, here's a couple notes here. Vertex form. Y equals, should write this down. Y equals A times x minus h squared plus k. Where have you kind of seen this before?
Absolute value.
Absolute value. Absolute value is very similar to this. So, if you know absolute value, you're going to know what this is then. So, HK is the what? The vertex. So it says that right here. So key points. After you write this equation down, key points. The vertex is h comma k. Next, if you know the vertex, what do you know? Yeah, you know the axis of symmetry if you know the vertex. And if you know the axis of symmetry, you know half of the vertex, right? They're with each other. Don't have good vocabulary today. The axis of symmetry is, notice, x equals h. Don't just write me a number. Don't say the axis of symmetry is 5. I'll take off a point for that. Okay? X equals. Lastly, you know this part. If a is greater than 0, it opens up. And a is less than 0, it opens down. So, just a few key ideas here. So, what can you get from this? A translation. If you know the vertex, you know how much it translated. You know, right 2, up 1, whatever it is. It all depends on your h and k. That's where it translated. Like this, the parent is put right here, h and k. Moved it this much, this much. Okay, whatever the h and k is. Alright, so those are some keynotes for vertex form. Why is it called vertex form? Shows you the vertex, right? If you see something like this, you say, oh, that's vertex form. So I know the vertex, right? Alright, so example number 1. Graph a quadratic function in standard form. Now we're mostly going to use our calculator for this, but what should we write down first before we go to the calculator? Okay, vertex. Should we do negative b over 2a? No, because this is in vertex form, right? So your vertex is just looking at this thing, which is negative 2, comma 5. And the common mistake is people putting what? Positive 2, right? But it's x minus h. So that's why it's negative 2 here, right? So negative 2, comma positive 5. There we go. So if we know the vertex, we know the axis of symmetry. X equals what? Well, if we go back to our equation, what was it? X equals h. So therefore, x equals, here's our h. X equals negative 2. That should be the start of your graph right there. I wouldn't type it in the calculator until I wrote down those two things. Just like I would for standard form, I wouldn't type it in the calculator until I found my vertex and my axis of symmetry. Okay? So, on your graph, you would just plot the vertex. Negative 2, comma 5. Plot a vertex. And these always draw the axis of symmetry. So, it's right there. X equals negative 2. Now, to get my points, now I would use my calculator. Could you not use a calculator? Yes, you could plug in some x's, get some y's. You don't want to do that. That'll take a lot of time. But you could. Okay, so type this in your calculator exactly the way you see it. Anytime you get a fraction, I always put a fraction in parentheses just in case. Okay, negative 1/4 in the fraction there in parentheses times x plus 2 squared plus 5. Type that in. Everybody type it in your graphing calculator. If you don't have one, I got a few back here. Oh. Alright. Type in your graphing calculator. Hit the table key. We're going to look at our table and it's going to tell us everything we need to know. Tell us all our coordinates. So, look at your table. What are some coordinates here? X, Y. Here's what I do. I've always put my vertex in the middle. I always put the vertex right in the middle so that I get points on one side and the other side. That's why. Alright, so I'm going to look at -1. I'm going to look at 0. I'm going to look at, actually, that should be on this side, right? Oh well. So -3, -4. My table is going to be a little backwards, but get the idea. 0, comma, what? I got 4? -1, comma?
4.75.
Okay, 4.75. And -3, comma?
-1.25.
-1.25. -4.
-4.
4? Something seems to be off. Because it should be symmetrical, right? Yeah, -3 should be 4.75 because this is symmetrical, right? This is in the middle. Well, it has this point on both sides. It has 4, 4. Should be symmetrical. Okay. So let's plot these real quick. 0, comma 4. There we go. -1, 4.75. -1, 4.75, somewhere up here. On the other side of this thing, -3, comma 4.75, and then -4, comma 4. Notice a symmetrical thing here. Draw a curve, please, not an absolute value, but a curve here. Should look something like this on your paper. Know how to graph. Okay, calculator does a lot of work for you. Use it. Okay, let's see. Let's go over comparison real quick. Tell me one thing if you had to compare this to the parent. Rachel? Opens down. There's one. Next. Matthew?
The vertex is -2.5.
Okay, just give me a little bit more.
Translation.
Not, you could, but just you got to compare. So all you're doing, you're stating a fact. So compare it with the parent. So the vertex is -2.5.
It's 5 up 2 to the left.
That's true compared to the parent. I'm saying while the parent is, here's what I would add. While the parent is 0, 0. Okay, something else, Monica?
So it's maximum because A is positive.
Okay, that's true, but that's not what we put in a comparison. Okay, that's true, but not what we put in a comparison. Okay, Jordan, what do you think?
It's wider.
Wider? Okay, how do you know? Based on
For A value.
the A. Okay, the A value tells you it's wider. And one more, Christian.
So you already agree what the vertex has axis of symmetry and
Nope. Axis symmetry.
x equals -2.
Okay, so last comparison, x equals -2 is the axis symmetry. Give me more. It's a comparison.
Compared to x equals 0.
Yeah, while the parent is x equals 0. Those are the things I'm going to look for on your next quiz and test. Okay? If you don't tell me all of those things, I may take a point or two off for not giving me a comparison. Okay? Any questions? Alright, know how to graph in vertex form? Next question. Alright, so it shows you a little picture here. And if you can see it, the y-axis is right here. Okay, there's your y-axis. Here's your x-axis right here, if you can see it. Now, let's see. Has 2 towers. This bridge has 2 towers 307 feet above the roadway, connected by a suspension cable. This makes a parabola shape, so therefore we can make an equation out of this. But it already tells us the equation, which is good for us. Okay, so write that equation down. What does it want though? says each cable can be modeled by that function. So this function right here is saying this represents this cable right here. So what does it want to know? Where x and y are measured in feet, what is the distance between the two towers? I'm going to give you a minute or two to find out if you can think about what the distance is between these two towers. You see where the towers are? Right here, that's one tower. Right here, there's the other tower. I'm going to give you a couple minutes to see if you can figure that out. Alright, John, tell us your explanation, Ben.
Vertex is 1,400.
Okay, so up here I'm going to say right here should be 1,400, 27. That's what everybody should have got out of the equation, right? So therefore, what's your logic now?
That's like midway, since it's a reflection, that means one side is 1,400, and the other side is
There you go.
just multiply.
Yep,
2,000.
there you go. So this is like halfway in between, right? Halfway in between the towers. Well, you just think about that x coordinate. That's 1,400 from here to here. So therefore, it has to be 1,400 from here to here. So 2 times 1,400, 2,800 feet. So just using this right here, it's like halfway, right? So from here to here is 1,400. The y value is 27, but that doesn't matter. But the x value is what we're looking for. So there you go. Good job. That was about it for that one. Okay. Label vertex axis symmetry. You should be able to get that just by looking at those. So you should be okay. Just don't get the negative sign mixed up. Now this one takes a little more work. The other one's kind of easy because it shows you the vertex. And the vertex is like the key to the whole parabola. But this one doesn't show you the vertex. So write this form down. This form is called Intercept Form. Why is it called Intercept Form? Because what this form shows you is the x-intercept. Some people might think why, but actually it's the x-intercepts. So you might want to put that. Shows the x-intercepts. Alright? So look at this form, write this down. Y equals A. We got A, that's nice. A still tells us all the same things as it did before. But you got x minus p, x minus q. All you have to do is say, oh, this point right here is p. This point right here is q. Oh, let's put them in here. And then you have your equation. If I told you the x-intercept was 3, 0 and 5, 0, you would just put 3 and 5 in for p and q, and you'd have your equation. But how do you find the axis of symmetry for one of these things? That's a little bit different. So you want to write this down right here. Axis of symmetry is halfway between p and q. So look what we do. We take p plus q and divide by 2 because it's halfway in between. So therefore, we have our axis of symmetry is this. Don't use negative b over 2a because that doesn't apply here. And so if you got intercept form, please use this to find your axis of symmetry. Lastly, if a is positive, then it opens up. A is negative, it opens down. Same thing as before. Okay, so 3 key formulas so far. We got standard, we got vertex, and we have intercept form. Let's go use it. Alright, so if you, people might need a minute just to copy a couple of things, but here's your axis of symmetry, and this is x equals p plus q all over 2. And then you got your equation here. Just memorize a couple things here and you should be okay. Alright, so let's use it here. Graph this thing right here. Well, very first thing before I graph, find the vertex, find the axis of symmetry. So you just have to remember, oh, this is this is intercept form. It shows you your intercepts. So what are our intercepts? The intercepts are, where does it cross the x-axis? What do you think?
3 and
Okay. Now here's you have to pay attention to the little details. Go back to the formula. What was it? It was x minus P and X minus Q. And here's where people miss that stuff. People understand the concept, but those little things is what gets people. It makes me sad sometimes. I hate it when that happens to people. So always be very, very thorough in what you're doing here. So since it's X minus P, we could change this to X minus negative 3, right? So what is P? Negative 3. This is X minus Q is actually just 1. That's where I'll get people right there. So the intercepts are negative 3 and positive 1. Write that down first. Next, what can we get from these intercepts? We can get the axis of symmetry. You just have to remember this. X equals P plus Q all over 2. Let's put them in. P is 3, negative 3. Q is 1. Negative 3 plus 1 all over 2 equals negative 2 over 2, which equals negative 1. Axis symmetry is X equals negative 1. So far on our graph, we could find the vertex. We're going to find the vertex in a moment. But I'm thinking this, if it's a rough sketch, negative 3 is my 1 intercept, so I can plot it here, x-axis. Positive 1 is my other intercept. I plot it. My axis of symmetry is x equals negative 1. That makes sense. That's right in the middle. Now we get our vertex somewhere in here. So put in negative 1. So vertex negative 1 comma something. So all you have to do is put it in up here. Put negative 1 in for x. So we'll rewrite it. Y equals 2 times x is now negative 1 plus 3 times x minus negative 1 now becomes negative 1 minus 1. Just do a little bit of work. I like finding the vertex with this. This is easier. 2 times negative 2, which gives you negative 8. Everybody understand how I got the vertex? Just plugging in the x equals negative 1, and that'll give you your y value for the vertex. That's also your what then? Your what?
Minimum.
Which one is it? Yeah, it's your minimum because this thing goes up. So your min is actually negative 8. So if I asked what's your min, you'd say negative 8. But you don't have to tell me that. Well, I'm not going to be able to graph that one on here. Negative, I'll just put a bunch of things and put negative 8 right here. Now what I want you to do is I want you to get a couple more. Just a couple more points from your calculator. And you can do that later. Okay? But all you have to do is, once again, type that in, go to your table, and it'll show you all the coordinates. Okay? Get a couple more and then you graph it. So that's how you graph something in intercept form. Any questions so far? So vertex form, intercept form, know both, know how to do them. Okay, well, those are two forms. What's next? Okay, a little word problem again. Use a quadratic function in intercept form. So notice this, it has a picture. Nope, no picture. But think of a football. You guys, I don't know if you know football or not. Okay, you got a football here. Okay, not soccer. You kick it, and what's the path of the football? Looks like a parabola, right? You kick it up in the air. Okay. Now look at what they say. This path can be modeled by an equation. Here it is. Y equals all this. Where x is the distance in yards, y is the height of the ball. So you could put this on a graph right here, like this. Here's my x-axis. Here's my y-axis. The ball starts here. It's get kicked up here. That's a rough sketch, obviously. We don't need. I don't think we need a perfect sketch. It says, how far is the football kicked? What do you think we'll be looking for? We'll be looking. What is that thing? What is that point? We're gonna use it, but that's not what I'm thinking of.
Oh, it's where the
like eats the x-axis.
That kid's kicked up in the air. Yeah. It's where the ball lands. The ball lands right here, right? What is that thing right there?
It's the x-axis.
One of the x-intercepts. We just have to find one of the x-intercepts. Look at the equation. What form is that?
Intercept.
Yeah, it tells you up above, huh?
No, it's Vertex.
Yeah, people get confused with this one. If you think about it for a second, it's not vertex form because it's not x minus. It looks like x minus h here, but that's actually not it. If I change this, look what I would change it to. Negative 0.026x minus 0. Isn't x the same as x minus 0? Alright, so I just switched it. And then x minus 46. Now look at it. So you might want to kind of star this. I mean, this confuses people. This is actually intercept form. Okay? Because x is the same as x minus 0. Okay? So be careful with this one. So since it's this form, what do we know? We know
The x-intercept.
x-intercepts. Here's 1. It says 0, right? There's 0. What's this one? 46. How far was the ball kicked? 46 yards. There you go. That's simple. Okay? So you got to know your forms really well and be able to apply them. Okay? Yep.
If the first x-intercept was like 1, would it be 45 yards?
Yes, it would be. Yep. Good. Let's see. Second question. What is the football's maximum height? What are we looking for? Vertex. How do you? I'll let you do it. You think about how you find a vertex in this form. Go ahead. I don't remember. Probably. That's okay. So what is the football's maximum height? Sure. Okay, so if you're doing this by hand, if you're doing this by hand, you really want to find the axis symmetry, which leads you to the vertex. So x equals p plus q divided by 2, which equals what? 0 plus 46 divided by 2. 46 divided by 2. 23 is the x coordinate, right? 23 comma something. So put 23 in here. So 23 minus 46 times it by negative 0.026. Yeah, that'll probably give you a decimal there. So if you multiply those three things together, if you put in 23 here and you put in 23 here, what do you get? Who got that one? Chow, you get that one? 13.754. Anybody confirm her answer? Okay, 13.754. So we can say 13.8. So what's a football's maximum height? So this is 13.8 approximately. So just put 13.8. I'll get people who put the whole coordinate again. It's just asking for the height of the football, right? So height is 13.8. What? Yards. There you go. There's how you answer a couple word problems in these forms. Know how to do those? Let's see. Example number 5. So I want you to be able to graph in intercept form and vertex form. FOIL method. Okay. Now, you guys remember FOIL? If I said x, if I put this y equals x minus 1 times x plus 3. You guys remember FOIL? F stands for first. What are we doing here? We are,
Distributed.
okay, there's a distributed problem. We're going to multiply these two things together, right? How do you multiply one binomial times another binomial? Well, FOIL. First, outer, inner, last. What do we multiply? We multiply the first two things together, which are, what are the first ones? Here's first. What's the other first? X. So here's first times first. So I'm just going to write it out for now. X times X. We always put a plus, but keep the negative sign. If there's like minus signs, keep them negative up here. Plus outside. So on the outside, here's X on the outside. Here's 3 on the outside, the outer part. So X times 3. Those are the outside. Plus I stands for inside. On the inside, these two right here are the inside. So negative 1 times X plus the last ones. Negative 1 is last and 3 is last. So negative 1 times 3. Hopefully this is a refresher and you get this real quick. Okay, because that's all I'm going to spend on it. FOIL right there. From now on, I'm going to assume you understand FOIL, unless you come see me. Alright? X times X, X squared. Plus X times 3, 3X. This is minus X. This is, I'll just write plus negative 3, but I'll change that up in a second. You always do like terms. Plus 3X minus X becomes X squared plus 2X minus 3 equals Y. What did we just do? What was this right here? True, we foiled. What was this right here? Intercept form. 2. Standard form. That's what we just did. That's what I want you to be able to know how to do. Go from intercept form to standard form. Okay? Use the FOIL method. Here we go. Change from intercept to standard. You go ahead and do this one. What I would do is I would multiply these two, and then in the end, multiply by negative 2. That's what I would do. But it's your call. Go for it. Okay, here we go. I would multiply these. Here we go. I'm going to do it quicker though. First times first gives me X squared. Outside, X times negative 8 gives me minus 8X. Inside, plus 5 and X plus 5X. And last, 5 and negative 8 becomes minus 40. Put these two things together. X squared minus 3X minus 40. But I didn't. People do this. I'll do that sometimes. I'll forget to multiply by negative 2. So make sure you do that. Negative 2x squared plus 6x plus 80. This is standard form. Now if you graph this one and this one, what do you think would happen? Same thing, just different form. Just like if I said graph this in slope intercept form and graph this in standard form, you get the same thing. Right? Doesn't matter. So be able to do example type number 5, changing forms. We're also going to change forms for right here. Vertex to standard. People miss these more than they do the other one. Okay? Why? Because what do you do right here? People try a shortcut, and there is a shortcut, but people will use the shortcut when they shouldn't use the shortcut. So here's how I'm going to show you. What does x minus 1 squared mean? Yeah, this means, if I say what does x squared mean, you would say x times x. Right? What does this mean? This means x minus 1 times x minus 1. Put a 4 out here, plus 9 on the end. If I were some of you, I would definitely do it this way because people try a shortcut and they miss it. So, FOIL these two, which means x times x, x squared. X times negative 1, negative x. Same thing here. Negative x. Negative 1 times negative 1 plus 1. But that's all times it by 4. And then plus 9. Clean this up a bit. X squared minus 2x plus 1 times 4 plus 9, and do some distributive property here. 4 times x squared, 4x squared, minus 4 times 2x, 8x plus 4. Then you still got plus 9. Be thorough in all your work. Okay, doing a bunch in your head doesn't help sometimes. 4x squared minus 8x, and these two are like terms, so plus 13. Make sure you put equals y or equals f of x. Okay, there you go. Any questions on changing to standard form from Vertex? You guys know the shortcut to do that one? I'll just do it off to the side, but please don't rely on the shortcut. Shortcuts leave you short sometimes. Here we go. Here's the shortcut. Take this one, square it, minus, in this case, since this is minus, I'm going to put minus here. What is it? 2 times whatever these two guys are. So 2 times x times 1 gives me 2x. And then you square this guy right here. Negative 1 squared is plus 1. There's the shortcut. But here's the shortcut that people do. They take this and they square it. And then they take this and then they square it. And they don't have this part right here. So don't let that be you. Alright? Alright, here we go. So that's basically it for section 2. No vertex form, no standard form, no intercept form. You be able to graph, be able to change forms, be able to do word problems, know what they're talking about. Is there any questions here?